So welcome back. Last class, we talked a little bit about angles formed in these scenarios. If I were to tell you that this is 70 degrees, could you tell me the value of X? Give me a thumbs up if you believe, yes, you can. Give me a thumbs down if you think, no, there's not enough information there to say that. A couple people are catching the little minor thing. I can't go from this north shore to this south shore unless I know that these lines are parallel. Agreed? So now let's say they're parallel. Now can you find those? Find the value of X. Okay. Somebody please tell me the value of X and explain why. Yeah.
70 degrees, because if you take like 70 like at the top,
right,
it's vertical angle, that's also going to be 70.
Good.
And then alternate interior angles are the same, so that's going to be 70. And then you take that vertical, and that's 70.
Okay, you guys agree with that? My only concern with it is very logical, and I love it, is that she assumed that the alternate interior angles are congruent. Is that true? What's the overarching theme in this course? How do we know when something is true? Did you just believe that because I said it was true? Don't we need to prove it? If it's a theorem, if it's a rule that is definitely true, I should be able to prove it. So that's what today is all about. Today, we're going to be proving alternate interior angles theorem, alternate exterior angles theorem, same side interior angles, and same side exteriors. You'll notice that the intention of all these things is to prove a theorem. So this is the theorem we're trying to prove. Now you'll notice something about this theorem. How is it written? You notice it's an if-then. It's written as a conditional. If two lines cut by a transversal are parallel, then the alternate interior angles are congruent. So what's the hypothesis? Very good. Turns out when you want to prove a theorem, the hypothesis is exactly what you need as the given, which means it's exactly what goes in this first space. So in general, I want to prove that if two lines cut by a transversal are parallel, something is true. Specifically, I've got a picture over here. And so I need to demonstrate what it is that I need. Well, I need L and M to be parallel. And I need T to be a transversal. That then satisfies my hypothesis. In other words, sets up the scenario that this is the world we're operating in. Now we have to prove that alternate interior angles are congruent. In other words, the conclusion of our theorem is going to be the same thing as what we're trying to prove, is going to be the same thing as what we get in the last step. We're trying to prove that alternate interior angles are congruent. So up here, which angles are alternate interior? 3 and 6. So I'm going to prove that 3 and 6 are congruent. Now, I've just added in this idea that the hypothesis is the given and the conclusion is the proof. But otherwise, we should be able to do a couple of steps. What goes here? What's the reason for this first step? Given. Good. And what goes down here? Angle 3 is congruent to angle 6. Good. This is where I said you should be at proofs by now. You should recognize that it's a two-column scenario. You have statements on the left, reasons on the right. Your given is the first statement, justified by the word given, and your prove is the last step, and we don't know what goes there yet. Will it ever be the word prove? Never, never, ever, ever, even though it says it there. Now, this is where you guys don't know what you're doing in doing proofs. I acknowledge that, but I'm going to walk us through that. This proof has really three parts. This is the first part. It's going to establish that we can get one of the angles from the North Shore and one of the angles from the South Shore to be congruent. We're going to bridge the gap of this river. So I'm going to start by saying two angles are corresponding angles. Which two angles here are corresponding angles?
6 and 2.
Good. Angle 6 and angle 2 are corresponding angles. I'm just saying that they are. How come I get to call them that? Because that's their name. My reason is definition of corresponding angles. Why was that important to establish that they are those angles? Well, we're going to use the theorem that we used last class, where we said if P, T corresponding, etc. I'm just going to write it out a little bit better. If parallel lines cut by a transversal form corresponding angles, then those angles are congruent. A lot of words. But again, this is a conditional statement. If parallel, transversal, corresponding. Previously in the proof, have we established that we've got parallel lines? Right there. Have we established that we've got a transversal? Right there. Have we established that we've got corresponding angles? We just did that. Remember that this is a conditional, and I've just shown that the hypothesis is true. What does the law of detachment then tell us? The law of detachment? It says if you have P implies Q, if P is true, what must be true? Q must be true. So if we know it must be congruent, then we can claim that angle 6 is congruent to angle 2. That gave us something. We've now got the North Shore and the South Shore tied together. We want to get 6 and 3. We've got 6 and 2. Who's left to get in the game? 3. So we need to figure out how 3 fits in. Well, 3 could fit in with 6, but since we're trying to prove alternate interior angles, that's probably not going to be known yet. We're trying to get to that in the end. What's the relationship between 3 and 2? They're vertical angles. So we say that angle 2 and angle 3 are vertical angles. How come? Why do we get to call them that? Definition of vertical angles, right? That's their name. And then we have a theorem. Remember the puzzle proofs we did? You guys did the linear pair theorem here in class, and I asked you to do the other one at your leisure. I'm not sure that everybody did, but what it proved was if they're vertical angles, then congruent. Good. By the way, you will be responsible for proving those. 2 weeks from today will be your test, and you will be responsible for all these proofs: linear pair, vertical angles, and then the 4 we're doing today. So if vertical angles, which we said 2 and 3 were, then congruent. So 2 and 3 are congruent. So that's the second part of this proof, is that we brought into play the other angle. Now we want to look at what we've got. If 6 is congruent to 2 and 2 is congruent to 3, then 6 is really congruent to 3. That's the transitive property of congruence. Notice that I'm saying not transitive property of equality, but transitive property of congruence, because these are all congruence symbols. So it's telling me that within the world of congruence, I can do this A to B, B to C means A to C. But this isn't quite right. It's not exactly what I wanted. So I need to change it to angle 3 is congruent to angle 6. What lets me swap sides?
Symmetric property of equality.
Good, symmetric. But not equality, right? Of congruence, good, because this isn't equality. This is congruence. And that's the third part, is tying them together. So I establish north and south together. I bring in the other piece, and then I tie those together. 5. I understand this proof very well. I think I could actually do this proof from scratch. 3. Scaffolded like this, I could fill it in correctly. 1. I don't know what you're doing up there. There's some crazy stuff on it. 2 to 4 is a very reasonable round size. So now what I want you to do is take the same idea and apply it to the bottom one. Proof of alternate exterior angles. You'll notice it's virtually identical. Start with north and south shore. Find the angle you want to get into it and put it together. Use the first one as a model. Go. That's all. So when we talk about transitive, it's really important that we have the order. For instance, if I get on a bus in Marin City and I go to San Rafael, and then I get a bus in San Rafael and continue on to Novato, it's like I went from Marin City to Novato. If I get on a bus in Marin City and go to San Rafael, and then I get on the bus in Novato and go to San Rafael, that's 2 different trips. That's not one 2-legged trip. So when we get down to the bottom here, and we've got our corresponding angles where we chose to do 1 and 8, and then our vertical angles where we chose to do 8 and 4, am I set up for transitive? 1 to 8, 8 to 4. That's transitive, isn't it? This one's okay to set up as is. When I apply it, I'm going to get angle 1 is congruent to angle 4. That's transitive property of congruence. But that's not what I wanted. So I need to do one more step to say angle 4 is congruent to angle 1, symmetric, which cleans up my mistake. If I had been smarter, could I have said 8 is congruent to 1 up here? Is there any problem with my having started with angle 1 and angle 8 are angle 8 and angle 1 are corresponding? Then I could say angle 8 is congruent to angle 1. That would have been fine. And if I had done that, I would then have up here angle 8 is congruent to angle 1. And then when I look at my vertical angles, I could have said, I'm not going to choose 8 and 4. I'm going to choose 4 and 8. And that would have then said angle 4 is congruent to angle 8. And now I would be set up for transitive to say angle 4 is congruent to angle 8. 8 is congruent to 1, which means 4 is congruent to 1 as transitive. I could have saved a step and not needed symmetric. Symmetric property is really just an opportunity for us to fix a lack of foresight in how we should number things. 5, I get this proof now, including the transitive nature. 3, I have some understanding of it. The transitive still confused me a little bit. 1, I'm kind of confused. Okay, the transitive will settle in. That's hard at first. I get that. Okay. Third proof of the day. This one's a little bit different. It starts the same. It still has the exact same given, which means my given here is exactly the same. L and M are parallel. T is transversal. And my first step has a reason of given. And I'm going to do my first chunk here. I want to get North Shore and South Shore together. So I'm saying 6 and 2 are corresponding angles. Definition of corresponding angles. And then I'm saying if parallel lines, which I've got, cut by a transversal, which I've got, form corresponding angles that I've got, then those angles are congruent. So angle 6 is congruent to angle 2, just like we did before so far. Now I'm going to leave this fourth step alone for just a second. I'm going to skip it. And then I'm going to go here. We're trying to bring in that other angle. We've got 6 and 2 already. We need to get 4 in the mix. But when I look at 4 and 2, what's their relationship? It's not vertical now. Yeah, I say they form a linear pair. The reason? It's definition of linear pair. And then I say, I know the theorem. If linear pair, then what? Yes. Which means if we've established they're a linear pair, which we have, the hypothesis is true, therefore the conclusion must follow by the law of detachment. So therefore 2 and 4 are supplementary. That's different than our last one. Now let's remember why we're doing this. We're trying to prove same side interior angles. If 2 lines cut by a transversal are parallel, then the same side interior angles are what? No, same side supplementary. We're trying to prove that these angles are supplementary, which means we want to get angle 6 and angle 4 are supplementary. And I chose what the order was based on what was written down here, because I know this last step is the same as what I'm trying to prove. So if 2 and 4 are supplementary, hold on, I see a lot of writing. Let me give you a second to get caught up. Okay, so if 2 and 4 are supplementary and 6 and 2 are basically the same, couldn't I just plug 6 in for 2 and say 6 and 4 are supplementary? Well, that's kind of the concept, but we don't have a plug in a congruence into supplementary and call it the same. That's not a rule that we get to use. So what we're going to do is we're going to use this step, and this step to tie these all together. I'm going to move them all into the world of equality. I'm going to say that if 6 and 2 are congruent, then the measure of 6 is equal to the measure of 2. That's the definition of congruent angles. And I'm going to take the words 2 and 4 are supplementary, and I'm going to apply the definition of supplementary to say what that means. It means that measure of 2 plus measure of 4 equals 180. Now I've got 2 things that are both in the world of equality, and I can take out the measure of angle 2 and replace it with the measure of angle 6 using the substitution property of equality, because this is equality now. And lastly, do you remember that definitions are bilateral? We talked about how a good definition is a valid biconditional, which means it's true for the conditional as well as the converse, goes both ways. So when we say the definition here of supplementary to go from supplementary to 180, we can also use the definition of supplementary to go from 6 and 4 equal 180 to calling them supplementary. So this last step is the definition of supplementary again. Five, I see it's more challenging, but I totally get this. 3, the addition of needing equations and fixing that in, that's a little confusing to me, but I'll work on it. 1, I'm lost with this supplementary one. Okay. Okay, good. Let's spend a few minutes now. I want you to try this bottom one. Follow the big chunks. Get north and south shore together. Figure out how 1 ties in, and then do the equation stuff so that you can communicate between the two. Students are working on this themselves, but I'm going to do this on recording so that everyone gets the notes. So if 2 lines cut by transversal are parallel, then same side triangles are supplementary. That's what we're trying to prove. So my hypothesis, L is parallel to M, T is transversal. And my given is now the specific application of this general. And now my conclusion is going to be that same side interiors are supplementary. So same side exteriors, that would be 9 and 3. So angle 9 and angle 3 are supplementary. So that's what I'm going for. All right, my given is here. L is parallel to M. T is transversal. Sure. And now I need to get the north and the south shores together. So I'll say 1 and 9. Angle 1 and angle 9 are corresponding angles. And that's because they are. That's the definition of corresponding angles. And once they're corresponding and parallel and transversal, I can say that angle 1 is congruent to angle 9. Because if parallel, transversal, corresponding, then congruent. Now this time I'm just going to leave that sitting for a second. This is supposed to be congruent. I'm going to leave that sitting there for a second, and I'm going to start the next part. I'm going to say angle 1 and angle 3 form a linear pair. Why? Because that's the definition of a linear pair. And if they're a linear pair, I know that if linear pair, then supplementary. They are a linear pair, therefore they are supplementary. Now the problem is I got to tie these two things together. Really, I just want to replace this 9 for 1, but I don't have a property that says replacing congruence in a statement. So instead, what I'm going to do is I'm going to turn this one into an equality. The measure of angle 1 plus the measure of angle 3 equals 180. That is the definition of supplementary. And then I'm going to take this one down here and say that the measure of angle 1 equals the measure of angle 9. That's the definition of congruent angles. If they're congruent, then their angles are the same, their measures are the same. And now I can combine these. Instead of measure of 1 plus measure of 3 equals 180, I can say the measure of angle 9 plus the measure of angle 3 equals 180. And I'm doing that by using substitution. Property of equality. Because these are now equals, so I can use the properties of equality. And in the end, if these two add to make 180, then that means angle 9 and angle 3 are supplementary. And that's the definition of supplementary again. Having achieved what I was going for, QED, quad erat demonstratum, I'm finished.